Part A of question 1 gives us a discrete time dynamical system, a DTDS, and it wants us to find all the equilibria here. This k is greater than 0 is a positive parameter. Isn't going to be of real importance to us on this, other than the fact that telling us that anything they talk to us about as being a parameter is a constant. And so when we go through a process like this, what it kind of says in my head is everywhere I see a k value here, I'm really going to treat that like a 5, like a number, as I do all of my work. So when we're going to find the equilibria, this is the, just what we would call the star game, right? So everywhere we see a w sub t plus 1 or a w sub t in this equation, we're going to start off by replacing all of those with w stars. And then once we do that, we're just going to solve this equation to get w star by itself. So the first thing that I would do on one of these is I would take this 2/7 w star and just multiply it through this back set of parentheses here. That's going to give us w star equals 2/7 w star k minus 2/7 w star squared. So w star times w star gets us w star squared. Anytime I have a power of 2 or greater whenever I'm doing an algebra problem like this, 99 times out of 100 the way to solve this is always going to be the same, which is you just want to get this equation set equal to 0 and then factor it. So the one move I need to do right now is move this w star over to the other side. So I'm going to subtract w star from both sides. That's going to give me 0 equals 2/7 w star k minus w star minus 2/7 w star squared. So the factoring in this situation is really just noticing that what we have going on in this problem is we've got a w star in each of our 3 terms here. And so what we can do on a problem like this, the factoring would be to pull a w star out of each one of those. So from this piece here, when I pull the w star out, that's going to leave me with 2/7 times k minus, when I pull a w star out of here, this is the one everyone usually drops off, but really when I pull the w star out there, I'm left with a 1 minus, and then in this last term here, I had 2 w stars, so while I'm pulling 1 out, I'm still going to have 1 left over in the problem. The reason we want to factor is now that I have 2 things being multiplied, I know that whenever this piece, whatever it happens to be, whenever it equals 0, 0 times the second piece will always give me 0. And vice versa, I know that whenever this piece equals 0, so 2/7 k minus 1 minus 2/7 w star, whenever that equals 0, I'm also 0 times this other piece will always give me 0. So it allows us to break it into 2 smaller bite-sized chunks of a problem. So one of our equilibria is done. W star equals 0 is one of our answers. And from here, we just need to solve this second equation to get W star by itself. So the first thing that I'm going to do is go ahead and add a 1 over to the other side and minus this 2/7 k over to the other side. So I'm doing kind of 2 algebra steps at once right now, but they're not too bad, so I figure you can handle it. From there, I would see that 2/7 k minus 2/7 k, those would cancel out. -1 plus 1, those would cancel out. And so then what we're left with here is -2/7 w star is equal to, so we'd have 1 minus 2/7 k. At this point, just to get w star by itself, I just need to divide every piece by -2/7. So divide by -2/7, divide by -2/7. And so what we'll end up getting out of here in the end, the 2/7 are going to cancel on this side. So if I kind of move this algebra over here, I'm going to have a w star left equals, I can type 1 divided by -2/7 into my calculator to get a value out in that situation. So I would do 1 divided by, and then make sure I put that -2/7 in parentheses and hit enter. So I'm going to get -3.5 there. And then -2/7 divided by -2/7 is going to give me a +1, and then we've got our k that's still sitting there. And so that would be our second equilibria in this situation. Sometimes on these problems, they'll want just the positive, just the negative. This time they wanted all equilibria, so both of these answers are going to be good answers for our equilibria.